Hello and welcome back to today's episode from High Water Studio. Today we're going to try something a little different and combine our typical engineering discussions with some programming. And so today we're going to look at programming and modeling a manometer in Roblox. And by modeling, I don't mean necessarily 3D modeling. I've already done this kind of rough 3D model. But we're going to be looking at how to model one mathematically and how to script it. So that's what we're going to jump into right now. So just kind of quickly looking at the model here, the 3D model, we've got a tank, which is going to be our pressure side. And we have this pressure plate that is going to be sort of imagined as being part of a vent to vent the system. So basically our manometer is here, a little bit of a rough model here, but what we have is we have one side open to the atmosphere, as manometers usually are, and then on the other side we have it hooked up to this pressure vessel. So we'll be able to basically use the pressure vessel to pressurize this side, and we will look at the difference in heights of these fluid columns to determine what the pressure is, which is how a manometer works. We'll also be able to vent the pressurized side to go back to equilibrium. We'll also put some constraints on here because we don't want the pressure getting so much that it actually gets down into this bottom part of the manometer. We also don't want to vent anything more than equilibrium, right? We will not have negative pressure in here. Okay, so I've already hooked a lot of this up. I've got my piping, we got the pressure tank, we got the vent, we've got the inlet column, the outlet column, and then we're going to display the pressure here on this display. All right, well, let's get into the script. So I'm going to want to set up some variables to handle the different items that we just discussed. So we'll have a manometer, we'll have our tank, right? Oh yeah, we'll have our valve, which I think I called vent, right? And then we're going to have our inlet side. Let's just call it inlet. And our outlet side of the manometer. And we want the display, I believe, is the only other thing that we're going to be interested in. Okay, and actually let's get the surface GUI and the text label. Okay, now that we've got everything cached as these different variables, let's start setting up some of the logic that we can use. We're going to want a Boolean to determine whether or not we can actually pump the system, right? Because we don't want it to trigger very rapidly and basically overpump the system all at once. As if you've done work in Roblox, you've probably done that before. You have to set up some kind of timer, right? And we want to set our pressure initially at 0, and we're going to use PSI here and mercury. So we got 2 inch of mercury per PSI. All right, that's just a little comment there to remind myself. We have the density of mercury is 0.49, I believe that's pounds per cubic foot. Oh no, obviously not per cubic foot, per cubic inch. And then we're going to have our column height. Pressure divided by density. Now we need to set up some vectors to store some initial data, right? We want to have the columns as they are now. So we're going to call this equilibrium. And, oops, I'm going to set it as a new one. We want the inlet, inlet size, x, inlet dot size, y, and, no, don't spell and, inlet, oh my gosh, inlet size dot z. Okay. I'm not used to talking while I try to program. We also want the inlet, I'm just going to call it equilibrium position, like where is it right now, which really we should probably call it datum. It's like a vertical datum, but I'm going to stick with this. This is a vector 3, new vector 3, and so we have our inlet position x, yes, okay, and the same thing for outlet. Okay, great. And that is most of our setup. The only other thing we want to do is go ahead and set some kind of a text to our display, right? Display.text. And I want it to start off with the initial pressure. So I'll say pressure. And actually, let's do new line. To string. And the units. Okay. Okay, great. Now we can get into writing some functions. And the first function I want to do is actually going to handle the logic, I think is where we'll start. And then we'll do the touches, the touch on each part, right? So let's do a local function. And we'll call this one adjust column. I always want to put this squiggle brackets because I'm not all that used to Lua. So the first thing I'm going to do is recalculate the column height after, because we'll call this function after something's been touched, after the parts have been touched, either the pressure tank or the valve, right? So the pressure will change, we'll come back and we'll recalculate these things and reset everything. So we want to change the inlet size. So this is going to be basically its height, the height of the column. So I'm going to set this to equilibrium. So that's why we want to kind of remember where we started from. We need some kind of a reference. And then we're going to add to that a new vector 3 with the new information. So I believe, let me go back. I should have checked this to begin with. Yeah, so because this has been rotated, our x direction is our z direction, basically. Now you could, of course, use global coordinates, but I'm just going to go ahead and stick with this. So in this case, I'm going to have, where am I? Column height. So we're going to subtract the column height because we're going to be pressurizing it in this case. Or actually not. It just, because this is the pressure side, it's always going to be less than equilibrium, right? It'll never be a vacuum that pulls it up. And then we don't want to do anything with the y or z coordinates. Now, one thing about Roblox is we're going to be adjusting its size from the center of the object, from its center of gravity. So that means basically it's getting shorter from the top and the bottom. So we need to recalculate its position in order to keep it in the same spot, if that makes sense. Hopefully it does. So that's why we need this equilibrium position. In other words, where did it start? Some kind of a datum to start from. Vector 3. We're going to be moving it down. Now, because we are, actually I should explain all this, what I'm doing here. Because we have the column height is really the, let's go back and take a look at this. This is going to be the difference between the height of this column and this column, right? So this one's moving down, this one's moving up, and the column height is actually the difference between those two. That's really our pressure column. So that's why this is being divided in half, because each one, this inlet's moving half, the outlet's moving half, and half of that is coming off the bottom, right? So 1/4 of that change needs to be applied to the position. In other words, bring the position down so that it doesn't appear to have moved. Okay, now we're going to do the same thing on the outlet, except in reverse. Equilibrium plus a vector 3. So this one will be going up by half. Nothing on the y or z. And we will adjust this one up. Outlet, equilibrium position, plus a new vector 3. And this one's going to be, oops, I made a mistake on that, on both of these. So that's actually not in the x, it is in the y. Height divided by 4 and 0. Oh, no, that's actually right. Okay, so I didn't make a mistake. And so once we have made these adjustments, we're going to flip our Boolean to false. False, yeah, that's how you spell false. And we are going to update our display. Probably should have just copied that, but it's fine. Okay, and we're going to wait, if I can spell, wait 1 second, why not? And we will flip our Boolean again. Okay, and that is all we need to adjust those columns. That's all our math, basically. So, not too bad. Now we need to hook up our touches, our touch events. So let's do a local function, say on tank touch, part touched, even though I don't think we'll be using that. So this is where our Boolean comes into play. If can pump equals true. Oh, and I always forget that. Then, let's see. So this one's the pressure side, so we don't need another. Actually, let's do and, because we don't want this thing going all the way down into the torus, into the bottom part. So let's say inlet dot size dot x, so that's its size up, is greater than 1. So we'll leave just a little bit of it left. Then pressure is equal to pressure plus 0.5. And then we'll call our function, just call it. And we'll do the same thing for the vent. On vent, touched, touch, part touched. In this case, we're still going to check if we can pump. If can pump equals true. And I'm going to do a second one where I'm going to check if pressure is greater than 0, because we don't want this going negative. I mean, it doesn't really matter, but you know, I think just out of trying to keep this more realistic. Okay. I believe that's all of our functions, and then we just need to connect them. So let's see. This is called tank, I believe. Yeah, tank and vent. So tank dot touched connect on tank touch. Is that every time? Okay. And then vent, right? Yeah, vent touched connect on vent touch. Oops. That's how you save. Okay. And I believe that is everything. It should work, I think. Hopefully I got everything working. Oh, I am kind of a long ways away. So it looks like our pressure is already saying 0. If we come over here, it's a little hard to do on the Mac. And it's not working. Great.
Here's my output. Don't usually do this on Mac. Well, I can't tell if I don't see any reason why that would be a problem. Alright, I'm going to have to pause my video and come back.
Oh. Well, that's one problem. Hopefully that was it. I really need, see, that would have shown up in my output. I don't know where the output is on the in the Mac. There we go. Okay, good. So as we contact it, we got up to 3 psi. We can see obviously the manometer is being pressurized on one side, being pushed up on the other, and hopefully the vent works. It does not work. Dang it. Alright. What is up with the vent?
And where is the output? I don't know. Alright.
Oh, duh. Got to call the function. Awesome. One more time.
Should not have made this so far away.
Okay, we already know this part works. Let's go ahead and get some pressure on it. Ah, yeah, yeah. And we are able to vent the pressure, but oh, I actually touched the tank. That's what happened. Okay, so yeah, can't create a vacuum. Actually, I meant to put a little particle system in here too. I forgot, but that's it. I hope that answers any questions for like how to deal with pressures and uh, fluid columns as a result of pressure, how fluid columns are equal to pressures, and how to do this in simple programming in Lua. If you have any questions, go ahead and put them in the comments below. Thanks.